In this video, we're going to graph the curve y equals 1 over x squared minus 6x plus 10. Okay, so in order to graph this curve, we should begin by graphing y equals x squared minus 6x plus 10. Now, we can go about trying to find what the x-intercepts are to help us graph that curve. But when we do that, we see that it doesn't factor, so we use the quadratic formula, we get a negative under the square root. There are no x-intercepts. So let's get this guy into vertex form, and we can do that by taking half of negative 6, which is negative 3, squaring that, and getting 9. So we can say y is equal to x squared minus 6x plus 9 minus 9. Plus 10. What I'm doing here is completing the square, but if you have another favorite method of converting to vertex form, that's fine with me. What we end up with is the parabola y equals x minus 3 quantity squared plus 1. That opens up with a vertex at 3, 1, and there are no x-intercepts. The curve looks like that. Now, our first step is generally to find where is the x-intercept or x-intercepts and draw vertical asymptotes, but there are none here. There are no x-intercepts. The next point is to go to every point where y equals 1 or y equals negative 1, and the only point is the vertex. Now, after this, what we do is we have to think a bit. We say, okay, this parabola here, it's going as I go from the vertex, it's going up to the left, which means my curve needs to go down to the left, but it can't cross that axis, that x-axis, because that's a vertical asymptote. Now looking to the right, I see that my curve, the black curve, goes up to the right. That means the curve I'm drawing, the red curve, needs to go down to the right. Now obviously this is not part of the curve. The curve is just what you see there in red. And that's what it looks like, okay? And so we can say, by looking at that the domain is the set of all real numbers, because all are defined there. The range is the set of all real numbers, so long as that number is somewhere between 0 and 1. We can include 1 because the vertex does have a y value of 1, so 1 is a valid y coordinate, but 0 is not. There's no point with a y coordinate of 0. Now our increasing interval is going to be anywhere when x is in the interval between negative infinity and 3. Or like I've said in other videos, I actually prefer a square bracket on the 3 because the definition of increasing interval, to my understanding, would include the 3. But the textbook doesn't include the 3. It puts a round bracket. So either way, I would accept it. A decreasing interval, we've got x's in the interval from 3 to infinity. You can put a round bracket there, or, a square bracket. Or you could put a round bracket. Okay, now our positive interval, well, every single point there does have a positive y coordinate, and the curve is defined over all x between negative infinity and infinity, so that's our positive interval. And our negative interval, there is none. And in terms of asymptotes, the only asymptote is a horizontal asymptote at y equals 0.